Okay, I'm Joe Celko. I'm notorious for having been the guy that spent a couple of decades with ANSI standards and SQL. But before I became the great SQL guru, I was a statistician, and the first love was mathematics. What I've noticed is that we don't talk about data as data when we're doing our databases. We don't consider weights, measures, how we encode stuff and whatnot. So I'm going to go back to foundations and fundamentals, what really should be called data science, as opposed to whatever that happens to be this week if you're getting a quickie degree. Okay. I'm going to assume everybody knows Donald Knuth. If you're old enough and you went to school, you were taught from the Knuth, the whole Knuth, and nothing but the Knuth. His Art of Programming, in 8 volumes, is still a magnum opus. The joke was that if you wanted to check an indexing system, you looked at Knuth, he referenced everybody, and then you looked at Dijkstra, he referenced nobody. If you got those 2 right, you were okay in computer science. But Donald Knuth's first published work was the Patrese system of weights and measures. He was in high school at the time. And here's the Wallywood Illustrated parody of the metric system from Donald Knuth as a teenager. The bad news is, of course, that a lot of people invent their own encoding systems and stuff, and it's about as bad as the Patrese system of weights and measures, which is based on the thickness of Mad Magazine issue number 23. And by the way, if you go on Google, they have conversions. Their weights and measures conversions will get you units in the Patrese system of weights and measures. Don't do that at work, please. But when we talk about scales, measurements, and so on, basic terms. A range is how much, essentially, in my space, does it cover? I'm going to use the example of shooting at a target with arrows or with a gun. A wide range is a big target. A narrow range would be a smaller target. Or think about it, you measure highways using a chain, not a micrometer, which is, I used to do highway work, which is sort of a blessing. Granularity is how far down do you break up your units. A target with a lot more rings on it has a higher granularity. Granularity can give you the illusion of precision and accuracy and, oh yeah. My rule of thumb is that a number impresses people to the square of the decimal places. We actually used to compute highways in decimal feet, and some guys would actually carry it out to 5 decimal places. Have you ever tried to pour asphalt to 5 decimal places? But boy, it was there on in the reports. Precision is how repeatable a measurement is. If I've got a really good cluster of shots on my target because my gun's all in great shape, everything's tight and accurate, nothing's bouncing around loose, I get precision. Notice that precision is not the same as accuracy. Accuracy is how true to the bullseye I'm shooting. So I have a cluster of shots off to the side that's real tight, so good precision, but my sights are a little out of alignment, and I'm not very accurate. Or I can take a shotgun, aim dead center, and get a great deal of accuracy, but not, it's going to be a lot more scattered than what would normally be there. Lots of rings, higher granularity. Wide cluster of shots centered around the bullseye is accurate but not precise. A tight cluster of shots off the bullseye is precise but not accurate. Important concepts. There's also the idea of a 0 point or origin where the scale starts. Not all scales have this, but that's where it begins. There's also the idea of a metric function, which essentially is the triangular inequality law in terms of measurements. It has nothing to do with the metric system, but it's a nice convenient property if we can get it. So what kind of scales do we have? Simplest one, nobody for a long time thought of them as a scale, but nominal. I'm just going to give things a name or a tag number or a character string. In the Renaissance, the Italian stonecutters that were working for Michelangelo and crew were illiterate, and they used marks. They used symbols for each of the families that bought stone from them. A real tag number done in crayon. No calculations, and about all you can ask is, are you this name? Is that Fred Jones? One of my favorite current t-shirts that's not obscene reads, on a scale from 1 to 10, what color is your favorite letter of the alphabet? People will try to answer that because it sounds almost reasonable. People will think that a nominal scale can somehow be ordered and get some kind of meaning out of it. No, it's a name, that's it. The fact I can order the representation with numbers and with character strings is very nice and very handy, but it's and obviously impossible with pure symbols. I had a friend who taught American culture in China just before Tiananmen Square. Her classes were about 150 students, and they did accommodate her by giving her the students' names transliterated into Roman letters without any sorting, and never the same order from day to day. After all, it was only 150 students, and when you don't have the power of an alphabet or a numeric system, you are expected to simply learn and memorize. Hong Kong, I don't know if they're still doing it, but Hong Kong used to have a telephone directory of telephone operators contest every year to see who could recognize the phone numbers from names. And their operators were routinely doing 10,000 names from memory. You know, be grateful for little things like the alphabet. But do I measure them in groups, or, well, that's the next thing. How about categorical scales? If I put them in groups and categories. Same basic thing as nominal, no calculations and so on, but now I've got the idea of a set, of a group. So I got membership, I've got containment. Fido might be the name of my dog, but his category is dog, or bad dog, depending. And I can go up and have groups within groups, containment, unions, all that sort of stuff. Get a little more sophisticated in my scales. Problems with categories. What if things don't fit into a category particularly well? There's Robin Williams fans here. Do you remember one of his routines about God smoking a joint and inventing the platypus just to fuck up Darwin? Well, yeah, that's there. Your solution, if you ran into a Martian or something completely alien, what do you do with it? Well, make a new category was one choice. Make a miscellaneous category and throw them all in there. That gets a little dangerous. Or just exclude it and pretend it doesn't exist. The other question is, what are these categories like? People versus grains of sand. Commodity versus distinguishable units. Lots of problems there. An absolute scale is just a count. I can add and subtract on this scale. It's maybe the closest. This feels more like a real scale than nominal or categorical to people, but it's a very simple scale. The fact I can do simple arithmetic, but I have to have a few conditions. The elements have to be interchangeable, so it makes sense. There's no ordering within the elements. And what's fun is that we have special units, finally. Dozens, grosses, quires, reams. Oh, I'm sorry, going back one, which quire? The paper industry has a couple of different versions of reams. The six-pack, one of my favorite units. It does not apply to muscles when I'm using it. Is kind of interesting. In England, when they went to metric having their big metric wars, the metric madness. One of the dairies put out went from the dozenal egg pack to the decimal egg pack. You could buy a tin of eggs, T-E-N. And they did a big promo on it. People wouldn't buy it. The individual eggs were actually cheaper in the tin pack than they were in the traditional dozens, but you just don't buy eggs by anything but the dozen. It was a complete failure. I, on the other hand, have had no trouble moving from the 6-pack to the 12-pack to the 24-pack as my unit of purchase. I'm much more progressive. The other nice thing is I've got the empty set as my 0 point for this. So I'm finally starting to get that counting thing. The next one up is ordinal scales. It just puts an ordering on things. No operations, only comparisons. No natural 0. My favorite, because I had to take geology. I went to night school for most of my college. And we always got the weird classes. You know, the things that, oh, look, there's 5 people this quarter that really want to do this, so you better take it now to get your electives and stuff out of the way. There's a thing called Mohs Scale. It's for hardness. It's a geologist thing. Yes, there's the Rockwell hardness scale, which is much better, much more precise for manufacturing. But the Mohs scale, they give you a box and a pickaxe, and inside the box are mineral samples. When you go out, you whack a rock with your pick, you take it, and you put it against each of the samples, and you can say, oh, well, this sample is somewhere between a 5 and a 6. That's all you're getting out of it. There's no exact measures or pressure or units, but I've got an ordering. Here's another cute one with some of these. Scales don't have to be transitive. Scissor, paper, stone, the hand game, or what is it? Scissor, paper, stone, lizard, Spock. If you happen to be a Big Bang Theory fan. We like transitive because it lets us do predictions and orderings and calculations, but they don't have to be there. In fact, a lot of things involving people and preferences are intransitive. That's why it's going to be kind of fun to watch the Republican debates. Depending who survives, a less desirable candidate can actually win. It's called Arrow's paradox in voting theory. Rank scales are kind of like ordinal scales, but they have an origin. They're well ordered, and surprise, military ranks are an example of a rank scale. Can't do operations yet. Don't take 3 privates, put them together, and make a sergeant from them. But I do have a start. Interval scales. Finally, we're getting something that looks like what people think of as a scale. There's a natural ordering of units. Doesn't have to be an origin point. Arithmetic operations start to make sense. The unit's uniform in its dimension. The classic one for interval scales is the day, which we group into calendars. And I've got a metric function. I can actually talk about 2 days from today, 2 days ago, that sort of thing. I'm now starting to be able to do calculations with my data. Ooh, ah. Well, not all intervals have to be the same size for this. Log interval scales, things go up by an order of magnitude. My favorite, having lived in California, is the Richter scale. Each jump of a number on the Richter scale is an order of magnitude worse. The 7.8 was much more impressive than the previous 6 point something we had before that. Decibels, same thing. A lot of things that involve human perception of sound, taste, and so on fall on log interval scales. That's why your controls are not linear on a stereo. They're actually a log interval thing. Ratio scale, finally, we're at what we really wanted. I got this unit, and I express everything as a fraction or a multiple of that unit. Mass, volume, length, meter, liter, gram. And I can do really serious arithmetic on it. Yay, finally, computable data. Now, why were these scales important? Other than the fact it makes a nice classification, and we love classifications. The rule is that I have to convert one scale to a scale of the same type if I'm going to do conversions. Nominal to nominal is a word-for-word match, a French to English dictionary. Hopefully there's a correspondence there. Ordinal, I got two monotonic functions that I can map into each other, preserving the same order. Rank scales, Army to Navy ranks, or U.S. Army versus British. You have to watch out for some of the rank scales. In the U.S. Army, warrant officers have officers' privileges. They don't in the British system. So if you ever get stuck at an NCO club, you'll know why. The interval scales, a linear function that basically just shifts the origin point and maybe changes the steps you're taking, like going from the Common Era calendar. Yeah, it's no longer the Christian calendar, it's the Common Era calendar. Going from that to Muslim, to Chinese, to whatever. Everybody agrees on the day as a unit, they just bunch them up a little differently. Ratio scales, this is why we really like them. We get an exact conversion by multiplying liters to quarts. Oh, by the way, the U.S. is not on the imperial system. We're actually on a U.S. traditional system where the old quart, the new quart, and the liter are all a little different. The Brits were quite happy when they went metric because they got a little more beer. If we had gone metric, we would have lost beer. Do we see a pattern in my examples of measurement? Also, if I've got these units, I can do derived units by combining them. Miles per hour, time, and distance. If you get a chance, you can get a wall chart of the ISO 2955 standard for the definition of all the metric derived units. Now, gross generalization. If possible, you would like to store the base units in your database and then derive the units. Why? Because you can reuse it. If I've got time and mileage, I can get my speed, but time and mileage are kind of useful things in and of themselves as measurements. Again, gross generalization, but it's there. I don't know anybody remember the definition for pascals, unit of pressure for tires? Any metric people here? Oh, by the way, there's now only 2 countries that are not metric. Us and Liberia. Myanmar is switching. Yay! I'm sure that all of you who are doing business with Myanmar, any arms suppliers for military juntas here, will really worry about converting your forms over. As a summary, nominal's the weakest, and then bit by bit, they get stronger until you get down to the ratio scales. Okay, this is usually a class lecture, and at this point, when I was doing it, I would hand out 3x5 cards with the names of various things that you might want to measure, like hat sizes, ring sizes, and your goal as a student was to come in with as many different scales and measurements as you could come up for that. Has everybody tried to figure out exactly what shoe sizes and clothing sizes are like? Especially women. They don't work. Every manufacturer sets up his own little system, and it's as bad as the Patrozzi system of weights and measures. But for shoes, the official one is called Mondo Point, and it's a metric width and length combination that can be then translated back into British, American, Spanish, German, Japanese, and I can't remember the rest of them. But there's like 12 different shoe size systems in the world. Now, I hate to say this, everybody comes with 2 feet. Shoes have, while styles change, been essentially the same. So, and they've been a trade good for a very long time. So why couldn't we ever get around to standardizing shoe sizes? Of course, I'm coming from a non-metric country and saying this, so all the rest of the world can laugh at me now. Another one. Everybody else is on degrees Celsius. One of the people at the front desk would say, "It's 31 degrees out there." Yeah, that sounds like someone who's used to Fahrenheit in Texas. Now the other giveaway is, do you say Celsius or do you say centigrade? Depending how old you are. Okay, I've now got these measurements. Oh, by the way, that's the scales and measurements thing. You'd think that was really old, that went back to a statistician somewhere. No. It was invented in 1947 by a psychologist. Yeah. No idea why, but yeah, it's that new. Now, once I've got those measurements, how do I encode them? Well, I got to get them into symbols to get them into a database. So I got alphabets, I got numbers. I really don't want to use symbols if I can help it. If you look at the Unicode standards, all Unicode language support has to include what's basically a little subset of ASCII that consists of the Latin alphabet, digits, and some punctuation marks. That goes with every language on Earth. And a lot of languages that have Unicode but have been dead for centuries. The reason for that was so that when you get ISO standards, you would have the symbols available anywhere to encode it. So don't get fancy with your representations. No, I like math for numbers. On a scale from 1 to 10 thing. And I've got string operators for manipulating things. These days, I can actually put direct data into a database. Pictures. For a while, we were trying to do a lot of face recognition. The only place I know outside of the NSA that was getting really interested in face recognition was in Hollywood with the casting companies, casting calls. So you could actually put in a query for a Marilyn Monroe type and have it do the face recognition to come up with people that had a certain look. Nice way to extend your career, I suppose. Become a cliche. Okay, that Latin alphabet, no accents, no case sensitivity. If it's a cute one, if some positions can be numeric, then we disallow some alphas so that I's are not confused with ones, O's and zeros, that sort of thing. We also generally like base 10 when we're doing codes because the check digits will work better with base 10. And again, simple punctuation marks. Frankly, a period for a decimal point and a slash is about as fancy as I want to get if I have to design an encoding scheme. Display is important. Fixed length versus varying length. The length is part of the validation. Okay. Has anybody here tried to send a letter to England? Have you been able to figure out their postal codes? The zip code in the US is always 5 digits. The thing in England, if you look for the regular expression for validating it, goes on for about a page and a half. The regular expression. It can be between, I think it's 6 for some government offices and up to 12 for places, often some Scottish bog. It's a complete mess. They abbreviated the names and addresses of post offices that haven't existed since the late 1800s and made that their postal code. And you're thinking, oh God, nobody can be that. No, it's dumb. No, go to Japan or Korea. Go to Japan or Korea and ask about house numbers. They break their cities into chomes, into little sub-neighborhoods, and then the houses within that neighborhood are numbered in the order they were built. And if a house gets torn down, the number is not reused. They're busy switching. Korea's busy switching. And For what it's worth, the group that is opposing it, the westernization of house numbers in Korea, is Buddhist. A lot of those neighborhoods are named after Buddhist saints. You think we get crazy about stuff? We're not the only one. Okay, people tend to group and read things. The monster long number is fine for your computer, not for you. You chunk it off in groups. This is why phone numbers, credit card numbers, and so on are broken into patches of 3 to 5 digits. You can read them. The U.S. phone number, area, exchange, number. Well, actually, that area and exchange, the area code's fine. That's for real. But the next group, really, it's like the first 4 for the switching inside. They don't physically represent mechanical things. They used to, but that's long gone. So how do I screw up an encoding scheme? Well, the classic is don't allow for growth. My favorite was the Georgia auto tags in the 1970s because I was working on the project. We had just gotten one of those new mini computers from a company called DEC. Any hands here? Yeah? Before they killed themselves. And we were gonna be really cool and get it off the old punch cards. Okay, punch cards. Yeah, fewer and fewer hands. Slide ruler. But the original encoding scheme and punch card layout had one column for the kind of tag, and the kinds of tags were pretty limited: passenger vehicle, taxi, farm vehicle. There weren't that many of them, so we just used a little numeric code. Oh God, people love to do this. Let's make a list of our possible values without thinking, and assign a number to it. If any SQL Server users, the identity table column, how many people do you see will just throw an identity column on a table, stuff it, and with whatever the values are, and use that physical column number? But anyway, commemorative tags got popular because the state found out, hey, somebody will pay extra for this. And of course, once Georgia Tech got a commemorative tag, well, University of Georgia, the football rivals, had to have a tag. And when the veterans of this war got a tag, the veterans of that war had to have a tag. And when people had various causes and whatnot, those got added to the mix. Oh, look, fuzzy puppies. Okay, the result was there was more than 0 through 9 values in the column. But in spite of the fact it used to be a joke, you pulled on the new guys in the old mainframe shops, there is no such thing as a card stretcher. Do you ever do that to some? In the aircraft industry, it was sending somebody out to get a bottle of prop wash. For us with punch cards, it was get a card stretcher. I need to get 81 columns on this thing. Oh, those were good days. God, I miss interns and being mean to people. But but you can multi-punch on a key punch machine by holding down a key and then literally punches that had no meaning in the IPSIDIC encoding scheme that IBM used. The problem was we had 027s, 029s, and some UNIVAC key punch machines. Their multi-punches don't quite match up. So what would be a 0 and a number sign on one machine might be a 0 and a backslash or whatever. Too many decades, I remember all of the things. But each key punch operator had to have a list of the multi-punches. And somewhere in her deck, if she got messed up or switched machines, suddenly there's a lot of people buying tractor auto tags. Inside city limits. And it was just a complete mess. But that's what we did. We didn't allow for expansion. My other favorite was American Honda, this is back in the 80s, decided there would never be more than 10,000 dealerships for Honda in the United States. Because in spite of the Beach Boys song, not everybody was going to get a groovy little Honda. It's not a motorcycle, it's a Honda. Oh God, I am old. All they rented when they first got here, all they made was electrical generators, and they rented scooters, little motorbikes. That was it. There was no automobile division. In fact, if you're anybody here a Mad Men fan, follow that series? One of their things was they're trying to get the Honda account and being very Japanese about it. But at the end of it, one of the throwaway lines was, Honda's going to start bringing automobiles over. Really? What have they got? Oh, they've got these little tiny cars with 10 horsepower motors. Oh God, nobody's going to buy that. Oh well, it's their money. But they only allowed for, on COBOL with fixed length fields, they only allowed for 10,000 dealerships. That didn't work so well. So I had a friend who was a COBOL programmer in those days, and she was busy essentially stretching cards. They had to redo all of the programs to get the dealership, to get a valid dealership number in there, and change all of the screens on 3270 video terminals. Google that. It's fun to see exactly how anybody survived sitting in front of what's essentially a large X-ray machine. Those were horrible things. Okay, another sign, ambiguous codes. Ambiguous, yes, they did. People have done this. The old ISBN, International Standard Book Number, came out of England in their publishing industry. The 10 characters were broken into 4 parts: the language, the publisher, the book number within publisher, and then a mod 11 check digit. It's actually, this has disappeared in favor of the ISBN 13, which is now part of the EAN standard retail encoding system. But when they first did it, I could parse my ISBNs 2 ways, depending whether I had a big publisher who got just a few short digits and a lot of book titles, or vice versa with a smaller publisher. And there were about 15 or 20 books that had duplicate ISBNs. There's really no excuse for that, but we didn't have computerized things. Now, for what it's worth, for the language code, 0 and 1 are English, 93 is Esperanto, just in case you ever need to look at the back of a book, and in case I ever get translated into Esperanto. The other sign of an ambiguous code is when I start using too many miscellaneous codes. And, well, we didn't know what to do with it, so we put it there, and we'll get around to doing some stuff. Right now, anybody here working healthcare? They've just come out with the ICD-10, and the coding is it's an encoding scheme. It's the Dewey Decimal of Death. It stands for International Classification of Diseases, 10th edition. And it's a long alphanumeric code for everything that can happen to you. They added 68,000 new codes with the 10th edition. My favorites are a whole section for injuries from terrorism as a separate category. And of course, there's the wonderful sucked into a jet aircraft engine as a separate code. I think that's much more dramatic than the other injuries on surfboards from sharks, which is also encoded. And if you don't get it right, you might not get your claim settled. Of course, somebody who's been sucked into a jet aircraft, it's probably more like, did your burial policy include cremation? Well, it does now. The other bad thing, lack of support for the exceptions. Okay, SQL has the null. Yay, we're the first language to come up with that. Statistics, however, have had this sort of problem. We've got unknown and missing values. Okay, does anybody know the ISO sex codes? There's 4 of them, and it's not what you're thinking. 0 for missing, unknown, 1 for male, 2 for female, 9 for a lawful person, corporations, churches, whatever. Why did they use 0 and 9? Oh, I know. Fortran and COBOL. When you go to punch them in on punch cards, a blank in Fortran was read as a 0. So I could leave out the sex code if it was unknown. And 9s sort to the end, and I can hold down the repeat key on the key punch machine and fill it with 9s to guarantee that all of those will sort to the end. A lot of ISO codes go back to this 0-9 arrangement because of the physical key punch machine that we're using to put data in. Now, I've got overflows, underflows, errors in one field, multiple errors across more than one field, show a pregnant male, things that are impossible. There was a Spark committee. I cannot remember what Spark stands for. It was one of the very early IT standards groups. They came up with 14 kinds of missing data. And then a little later, there was a follow-up that brought it up to 22 different kinds of missing data. Watch out for that. You're going to have to do it on a case-by-case individual basis. Now, if you think that designing an encoding scheme is not important, try doing your checkbook in Roman numerals for about a week. The Romans didn't do calculations. They just recorded things with their numbering system. I mentioned alphabetical order. My friend Molly over in China trying to get a class roster with 150 students. I'm going to assume everybody knows the Dewey Decimal System, right? We got that beat into us in grade school. Did you ever think how libraries were arranged before Dewey Decimal? Yes, exactly, they were not. Each head librarian pretty much did whatever they wanted to. And having been in the bookstore business, I can tell you that feminist bookstores in the 70s liked to arrange their books by color. I wish I was making that up, but it looked pretty on the shelves. They were also smoking a lot of grass in the back. If I've got a good encoding system, queries, aggregations are a lot easier. And because of knowing that things really are accurate, your calculations also get more accurate on it. Okay, so what kind of encoding schemes do I have? Enumeration. It's a nominal scale under another name. Essentially, I order them, and I give them a symbol, give them a name. If I can have some ordering principle, life is a little better. Chronological, which values are going to occur first. I have to make a reservation before I can cancel it. Some things are obviously time dependent. Procedural, physical. Physical is kind of nice. I mean, you go out and look at a rainbow and you know the order of the colors in the rainbow. If you saw a rainbow where they were sorted differently, that's a little more disconcerting than finding a library that doesn't classify the books the way your librarian did. That's why we like alphabetical and numeric, if we can design them. That's why codes tend to have leading zeros and be fixed length. Now, the column in a database should represent units on a certain scale. We don't like doing mixed units. We don't like doing mixed attributes in a column. Okay, again, T-SQL users. They have a money data type in their language from the old Sybase days. It puts in commas and currency signs and decimal places. Why? Well, because COBOL programmers would have done that with what's called a picture clause and had the language actually do the formatting. But it was too scary in the early versions of a SQL server to go in and do all the substring and cut and paste and all that. So they built it into the language. And what's the rule about in IT? There's nothing more permanent than a bad patch. No one dares get rid of it. People use it, and it's still hanging around. The other thing with their money data type, by the way, is it doesn't do correct arithmetic. It rounds too soon, and it's illegal as hell in the EU. It's kind of like inventing a date-time data type for your language and forgetting leap year. Blah. Okay, abbreviation codes. I want a shortened version of the name of the value I'm doing, so where I get a one-to-one mapping. It can be variable or fixed length. It's designed for human readability. My favorite is the three-letter airport codes. Anybody can see LAX, okay, yeah, Los Angeles, I can get that one. BOS for Boston, ATL for Atlanta. That's pretty good. Yeah, I know when I look at my bag, it's not supposed to be here. Instantly. But at least yeah, I get the information fast. Really nice, and once I realize it's an abbreviation, if I see something strange, I'm generally okay. The bad news is that you can run out of abbreviations. Huh? Yeah. Look at the minor airports in the Alaskan outback. They've got W's and Z's for historical reasons going back to World War I or II. And if you don't know them, you're not going to guess them. BOS, Boston, yay. WWZ, not so much. Algorithmic codes. I've got a procedure, I take the value. It might not be immediately human readable. A Julianized date would be a very simple example of that, but the one you don't think about, encryption. I specifically don't want it immediately human readable. Rounding numbers is technically an algorithmic encoding. Hashing functions. I've got a process for reducing the value to a shortened form. Now, the ones I like, in particular, are the hierarchical codes. I take a set of values, I partition them into disjoint subsets, I partition the partitions, I build a tree. Life is good. It's usually numerics. It can be mixed alphanumerics. I've already mentioned Dewey Decimal Classification. You know, the 500s are science, the 510s are math, 514 I think is algebra. But I know as I'm going down the stacks in the library that I'm getting closer and closer to what I wanted. Library of Congress classification is mixed alphanumeric, and it's got the same basic properties. You keep narrowing it down. Oh, by the way, there's a lot of political fights about Dewey Decimal. The flying saucer people and the homeopathic people and the other raving nuts available in our culture want to have their particular Dewey Decimal numbers put in the 500s with the sciences. And they have petitions, I was about to say partitions, petitions and meetings and suggestions for the Dewey Decimal people. And you thought that running a library would be quiet. Zip code's another example that's used probably every day. It does partitions based on geography. If you want a really good example of that, hierarchical triangular mesh. Anybody doing geodatabases? Basically, it's instead of longitude and latitude, you take the Earth and start cutting it into geodesic triangles, and each triangle is numbered in a particular way, and then cut into 4 more triangles and numbered again. At 15 digits, about the length of a credit card number, you can get within a square foot of any space on Earth. It's really good for cell towers and satellites, as opposed, because you don't have a transit or anything, but it partitions everything on Earth into little triangles. Now, what can go wrong? You put something in the wrong place in a hierarchy, it's hell to get it out. Okay, when Melville Dewey was inventing this, mathematical logic had not been invented. Logic was a branch of philosophy. Aristotle, correct reasoning, syllogisms, blah, blah, blah. Or if you were a Buddhist, they had their own little systems. So along comes mathematical logic. Nobody's written a philosophical logic book in the Western world in 200 years. So problems. Now, how about I don't have enough space Another one of Melville's prejudices was against religion, Eastern religions. You were a Catholic, Protestant, Jew, or miscellaneous. Sort of like the old army dog tags. There are more books on Buddhism in the Library of Congress than on Christianity. They got a couple hundred years head start. They wrote a lot. What do I do if something doesn't quite fall into a nice category in my hierarchy? Church architecture and the worship service, should they be under religion or under architecture? Vector codes consist of parts that cannot be separated, and but each part has some meaning. My favorite is tire sizes. A 155 SR15 is 155 centimeters, SR for steel radial, the material, and then the diameter, 15-inch hubs. The diameter is going to go metric soon. And I need to take Social Security numbers off of this because Social Security numbers are now random and have been for about the past 2 or 3 years. We've had our invasion of illegals and duplicates and stuff. They finally gave up on any of the 3 parts having any meaning. Okay, concatenation codes. I just keep sticking things on a longer and longer string. You don't think about it, but the keyword list at the start of a journal article is a concatenation code. So is a checklist. We don't like the full stuff now in the computer day with computers, but in the old days, machine shop tags and other things, people would just initial. And as the thing went through and the initials collected, that became the state of the piece of work in machine shops. As I said, it's sort of fallen out of favor. Okay, guidelines. First guideline, get your ISO standards. They're online. You don't have to go to the library and pull out paper. You can get them in electronic formats. You can load them directly into your tables. Don't invent your own encodings. You have to maintain them. Nobody else will use them. Yeah, life is short. Allow for expansion. Watch out for the exception values. Make sure you've covered them. And this is going to sound stupid, but keep a translation of the codes for the users in the database somewhere. Not everybody knows your industry and can figure it out. I'm sure that the encoders sitting there filling out insurance forms with the ICD-10 codes, just off the top of their head, know what it's like to be sucked through a jet aircraft engine and can rattle that code off in nothing flat. Not everybody can do that. Okay, I'm pretty close to, I have 1 minute left. I can take questions, or you can throw stuff at me. But I just wanted to get you to theory and to think about things a little more abstract fashion. Okay, I'm done.